Hey guys, Mr. Kyle, Myers Mathematics, and let's just jump right into it. So today I want to talk about limits, just the basics, just the bread and butter of what limits are. So I'll maybe touch on infinite limits and the piecewise limits as well, or I might just save that for another video, so that way this one's not too long. But basically the steps to any limit. So when I say limit, I mean it looks like this, right? It's like as x approaches 0 of some sort of function. Okay, so this is like mainly for pre-calc, but maybe a little bit before that or after that, some trigonometry, any classes that are within, somewhere surrounding pre-calc. Okay, so let's just jump right into our first step, the very first thing you need to know to solve a limit, and that is plug it in. So for instance, if I say, let's just say I do the limit as x approaches 2 of x. Well, there's nothing stopping me from just plugging it in. If you can plug it in, plug it in. All right? Like Febreze, plug it in, plug it in. So it's just 2. The answer is 2 because I plug in 2 for x, and then I get 2 out, as my answer. That's it. Or let's say it was like the limit as x approaches 3 of x over x plus 1. Or let's say x minus 2. Make the numbers easy. If I plug in 3, I'd get 3 over 3 minus 2. Well, 3 minus 2 is 1, so that's 3 over 1, which is 3. So the answer is 3. And that's it. So if you can plug it in, try to do that. Try to always plug it in first. But, of course, it's not always going to be that easy. So if it isn't, then your next thing that you want to try to do is factoring. So let's say, it's doing that thing again where it doesn't want to switch pins. Hold on, let me try to do this manually here. Give me just a second. All right, so green, change to green here. So let's say I have the limit as x approaches 2 of x squared minus x minus 2 over x minus 2. Okay, so step 1, try to plug it in. If I plug in 2, what's going to happen is down here, this right here is going to be 2 minus 2, which is 0. That doesn't work. Can't do it. I can't have a 0 in the denominator. So step 1 doesn't work. So what I do is I do step 2. I'm going to factor this top thing here, right? And that's minus 1x. Anytime you have no number, it's a 1, for the same reason that if you said you had a pin, that means you have one pin, right? So that's 1x. So I want to have two things to multiply to give me 2. Well, really, 1 and 2 are the only two things, besides fractions, of course, that give me 2. And then I want a negative 2 when I multiply, which means one of them has to be positive and one of them has to be negative. If I do it like this, if I do a positive 1 and a negative 2, then I get a negative 2 when I multiply, and I get a negative 1 when I add. So x, there, I factored it. And then this is over x minus 2, and there you go. They cancel. So I'm just left with, this is the same thing then as the limit as x approaches 2 of x plus 1. I just canceled out an x minus 2. So now I just plug it in, right? Try factoring. We just did. We've canceled something. We got it down to this, and now this is just 2 plus 1, which is 3. So the answer is 3, right? Now, if that doesn't work, for whatever reason, you can always try a conjugate. So what do I mean by that? If I do a conjugate, that would look something like this. So for example, let's say I have the limit as x approaches 5 of x minus 5 over x plus 4 minus 3. Okay, so the problem with this is, step 1, plug it in, right? So 5 plus 4, square root of that, minus 3. 5 plus 4 is 9, so square root of 9 minus 3. Square root of 9 is 3. 3 minus 3 is 0, so I get 0 again for the denominator. But this time, there's not really anything to factor. So what I have to do is call the conjugate. The conjugate sounds a little bit like opposite. It sounds like opposite. Conjugate, opposite. They both have 3 syllables. They both have like similar sounds in them. All right, not exactly the same word, I get it, but opposite, conjugate, they're similar because they're almost exactly the same thing. So if I said what's the opposite, so let's say the opposite versus the conjugate. Okay, so if I have let's say x plus 3. Okay, if I have x plus 3, the opposite of that would be negative x minus 3. You change the sign on everything. Whereas the conjugate, you only change the sign in between the two numbers. Right? So that's exactly what I'm going to do. I'm going to multiply by the conjugate. Now, I'm not going to do the conjugate at the top because there's not really anything wrong with that. There's nothing wrong with this. Nothing wrong here. So I'm going to tackle the conjugate of this thing, which would be x plus 4. Yeah, it's still plus 4 because this is all one thing. So the square root of x plus 4 is all one thing, and then plus 3 instead of minus 3. So x plus 4 plus 3 multiply all of this stuff. So then, here's what I get. I would need to FOIL it out. So on the top, I'd have x times the square root of x plus 4. So x plus 4. Outer times the outer, x times 3, so plus 3x. Inner times the inner, minus 5 times x plus 4. And then last times the last, 5 times 3 is 15, but it's a minus. On the bottom, here's what happens. When you multiply by conjugates, the middle terms cancel out. So the first times the first would be x plus 4 times x plus 4. They're both square roots, so it would be like x plus 4 square root squared, x plus 4 square root. You're going to times it by itself, which is the same thing as squaring it, so that cancels, and I just have x plus 4. Then the outer would be x plus 4 and plus 3. Inner is x plus 4 and minus 3, so they cancel. I'm not even going to write that. I don't have inside stuff. I just have the first times the first and the last times the last. 3 times 3 is 9. It's a minus. So there we go. So on the top, I can't really do too much to clean that up there. X plus 4 plus 3x minus 5 square root of x plus 4 minus 15. Not really a whole lot I can do to clean that up. And spoiler, you can see the next step here, but I'm having to spill down a little bit. So then I'd have x plus 4 minus 9, which would be the same thing as x minus 5. Right, x minus 5. So x plus 4 minus 9. 4 minus 9 is negative 5, so that's the same thing as x minus 5. And actually, it would have been better if I hadn't distributed all this stuff up here. So actually, all of this, let's change this back to what it was back before I FOILed it out. It was totally useless for me to FOIL it. Before I FOILed it, it was x minus 5 and the square root of x plus 4 plus 3. That's what it was before I FOILed it. But now you can see, hey, look, that goes away. And that was the issue. Now I can plug in 5. So then I do that. I plug in 5. I get 5. I'm going to write this over here. 5 plus 4 plus 3. 5 plus 4 is 9. Square root of 9 is 3. 3 plus 3 is 6. The answer is 6. Whew. All right, so yes, conjugates are annoying. They're difficult to do all that math. It was a lot of math. But if you can't plug it in and you have square roots, then you might have to do a conjugate in order to solve the limit. All right, now, this next one, if you're in pre-calc, this is not something you've learned yet technically. So this is kind of a cheat method, and it works on pretty much anything as long as I get 0 and 0 for the top and the bottom. So for instance, let's say I have the limit as x approaches 0 of sine x over x. Right? And some professors, some teachers like to have their students memorize this one and cosine x over x because they both have limits as x approaches 0. But let's just look at what this would look like. So if I plug in 0, I get 0, right? I get 0 if I plug in. So that's a no-go. What I can do is, well, step 2, factor, can't factor. Step 3, try to do a conjugate, but there's no conjugate. There's one thing on the top, one thing on the bottom. I can't combine them. So L'Hopital's rule. So in order to know how to do this, you have to know what a derivative is. So this is kind of a cheat method. So if you're in pre-calc, you haven't learned derivatives yet, but derivatives are actually very easy to do. So derivatives. All right, if you have x, let's say x to the third, and we want to take the derivative of this, then what you do is you take the 3 out front, and then you have the x, and then it would be squared. There we go, we just took the derivative. Or let's say I have 2x squared. Okay, so you take the 2 out front, there's already a 2, so it's 2 times 2, that's 4. 2 out front, 2 times 2 is 4, and then subtract 1 from the power, so I just have x. Now, if I just take the derivative of x, like for what I'm about to do here, there's a 1 power here, so you would take the 1 out front, but then I subtract 1 from the power, x to the 0 power. Well, anything to the 0 power is 1, so the derivative of x is 1, right? And then the derivative of sine is cosine, right? So L'Hopital's rule says you can take the derivative of the top. So derivative is this little symbol, d over dx. That's the symbol for derivative. So if I take the derivative of this and this individually, the top and then the bottom, I get another thing that has the same limit value. So derivative of sine is cosine, derivative of x is 1. Now I can plug in 0. So I just need to know what the cosine of 0 is. Well, the cosine of 0 is 1. So the answer is 1. All right. So there you go. There's L'Hopital's rule. If you want to see some more examples of that, just let me know in the comments. Or if you wanted to see another video, I can link to another video on calculus, just simple derivatives. But if you're in pre-calc, don't think that derivatives are super daunting. They do get harder than what I showed you here, but the basic derivative is actually really easy. It's much easier than what they make it seem like it is in pre-calc. Right? So then we get to step 5, the final step. There's not really anything much to do here because it says if that didn't work, so if steps 1 through 4 didn't work, then your limit probably doesn't exist. Right? If we've done all the things, steps 1 through 4, and nothing worked, then your limit probably doesn't exist. So for instance, if I want the limit, let's change colors here again. So if I want the limit as x approaches 0 of 1 over x. All right, so step 1, plug it in. Can't do that. Be 1 over 0. No go. Step 2, try to factor. Nothing to factor. Step 3, conjugates. There's no conjugates. Step 4, L'Hopital's rule. Well, the derivative of 1 would just be 0, and then the derivative of x would be 1. So it should be 0, but anytime you get 0 for L'Hopital's rule, you want to be careful. Another side note there. Also, L'Hopital's rule really technically only works if you get 0 on the top and the bottom when you plug it in. So another little caveat there for L'Hopital's rule. But that doesn't really work either. So I'm kind of stuck with, hey, this probably doesn't exist. And if you want to be sure, you can always graph it, or you can plug in some values that are close to 0. If I graph this, it looks something like this, and like that. So it's going to approach the x-axis, and it's going to approach the y-axis. And that's where x is 0. The y-axis is where x is 0, so it's just not going to work. The limit has to approach a value. It approaches 2 different values. Down here, it's approaching negative infinity. Over here, it's approaching positive infinity. It's not even approaching the same infinity. So it's going to 2 totally different places. There's no value at x equals 0, so it just doesn't work. So it does not exist. Or I like to say like a 0 with a slash through it, D&E or 0 with a slash through it or something like that, or whatever symbol your teacher wants you to use, of course. But there you go. So there's the 5 steps to limits, and that is all you need to know to take any basic limit. So just any limit that's not an infinite limit, or for a piecewise function. Again, I'll put out another video on those. If you want to see a video on that, let me know in the comments. And that's it for today. So if you haven't gotten my free guide on my website, go check it out. It's the 5 math mistakes everyone makes and how to avoid it. You can grab it for free on my website, myersmathematics.com, all spelled out, and I'll put the website in the description as well. Basically, it's a guide that shows you there's 5 different ways that you can mess up on a math problem. I've narrowed it down to 5 things. There's only 5 things really that you can do to mess up a math problem, and I've got them all listed out in order with an explanation of what it is and what you can do to avoid it, and a quick little blurb on just the quick solution, and then the details are in the paragraph as you go. It's great. You should check it out and grab it. It's a free resource that I want you to have. So go grab that at my website, and I'll see you in another episode.